Hello, this is H2 o'clock. Today we are going to talk about our fifth concept video about flame test. Before or after you watch this video, please watch our experiment video about flame test. Here's the link. Let's start with orbital. According to the current theory about the structure of atoms, electrons are found around the nucleus in regions called orbitals. Orbitals show the potential place of an electron. They are located at different distances from the nucleus and have different energy levels. So they have different shapes as you can see in the first picture. Next is about ground state and excited state of an electron. The ground state of an atom is the lowest energy state of an atom under stable conditions. When the electrons in an atom absorb the energy from an outer source, like light, fire, or etc., they jump temporarily to higher energy levels. The electrons are now said to be in an excited state where its potential energy is higher than the ground state. As they fall back down to the lower levels, energy is released in the form of electromagnetic radiation. Each of these jumps involve a specific amount of energy being released as light, and each corresponds to a particular wavelength. When that electromagnetic radiation falls between 400 and 700 nanometers in wavelength, it is given off in the form of visible light. As a result, a spectrum of lights will be produced, some of which will be in the visible part of the spectrum. The color we will see will be a combination of all these individual colors. For example, there are many common metal ions such as lithium, sodium, potassium, calcium, barium, strontium, and copper. These produce a distinct color of visible light when they are heated because they have a unique electron configuration. If you want to see the distinct color, then here is the link of our experiment. Okay, why do they make different color? If, for example, you put sodium chloride, which contains sodium ions, into a flame, the electron in the outermost shell excites to a higher level electron shell and comes back to original shell. In this process, the energy is released and it makes yellow flames. Using these properties, we can conduct a flame test in which we can identify the elements. The test involves introducing a sample of element or compound to a hot flame and observing the color of the flame that results. The idea of the test is that sample atoms emit light when being in flame due to electronic transitions between different atomic energy levels. Those transitions emit light at very specific frequencies, depending on the characteristics of the chemical element itself. Therefore, the flame gets the color, which allows us to determine which element that is. Last thing we are going to talk about is emission spectrum. An atomic emission spectrum is the pattern of lines formed when light passes through a prism to separate it into different frequencies of light it contains. The image below shows the atomic emission spectrum of hydrogen. When the corresponding light is passed through a prism or spectrograph, it is separated spatially according to wavelength, as illustrated in the image. Remember, every element has its unique atomic emission spectrum. So, this was about orbitals, flame tests, and emission spectrum. Was our video helpful? Please leave comments below. Wait for our next video and don't forget to like and subscribe us. See you next time.